In this lecture, we're going to talk about hypothesis testing for a mean. This is when sigma, the population standard deviation, is known. And in a previous lecture, we talked about the critical value approach. In this section, what we want to talk about is something called the p-value, right? Or the p-value approach to hypothesis testing. Now, we're going to rely very heavily on our TI calculator for this to compute our probability. So what exactly is a p-value? So in statistics, the p-value is the probability of obtaining results as extreme as the observed results of a statistical hypothesis test. And in this case, we're going to be talking about a hypothesis test for a mean. And this is assuming that the null hypothesis is correct. Okay, so in the previous lecture, when we did hypothesis testing, what we did was we computed a test statistic and compared it to a critical value. In this section, what we do is we compute a probability. Okay, and so we take a sample and we compute a sample mean. And what we do, and we look at that sample mean and we say, okay, what is the probability that, assuming that our null hypothesis is true, that we would observe results more extreme than what we just did? Okay, with this sample mean. And what happens is that this probability is low, like less than 5%, less than 1%. What it means is your results are statistically significant, and you probably didn't observe that sample mean by chance. What it probably means is that your null hypothesis is incorrect. Now, I'm going to show you how to use this p-value approach. It's actually, I think, a lot easier than the critical value approach, mostly because we rely on our calculator quite a bit. Okay, so how do you use a p-value? So you're going to compare the p-value of the tests of your hypothesis test with the level of significance. Remember, that is alpha. Okay, so you're just going to compare the p-value to alpha. Okay, and this is the two conclusions you would make. Remember, you can either reject or you can fail to reject it. So if the p-value is less than the level of significance, okay, you're going to reject the null hypothesis. So if p-value is less than alpha, you reject the null hypothesis. And if the p-value is greater than the level of significance, so if your p-value is greater than your level of significance, you fail to reject the null hypothesis. So a fun saying to help you remember this is the following. So when the p-value is low, the null must go. So when the null must go, that means you reject the null hypothesis. And when the p-value is high, the null must fly, unless it must still be fine. So you fail to reject the null hypothesis. And like with many things in statistics, after you see an example or two, this will make a lot more sense. Okay, so the 5 steps for this, for the p-value approach, are very similar to what we saw in the previous lecture. So steps 1, you're going to define the parameter. So in this case, it's going to be let mu equal something. And then you're going to set up the test. So you're going to set up the null and the alternative hypothesis. Okay, and you're going to have to choose if it's right-tailed, left-tailed, or a two-tailed test. And I have 3 examples here, so obviously we'll do one of each. You're going to select your level of significance. This is alpha. You're going to compute your test statistic here. All right, so we've done this a bunch in the previous lecture by hand. So in this one, what I'm going to do is I'm actually going to show you, believe it or not, your TI calculator does this for you. And then the next thing you need to do is you need to find the p-value of the test. And what you're going to do is you're going to use your TI calculator for this. And it's going to be very, very easy. Okay. And then step 5, your conclusion. So if the p-value is less than the level of significance, you reject the null. If the p-value is greater than the level of significance, you're going to fail to reject it. Okay. So your TI calculator does this very easily. And the option we're going to use the most here is you're going to use your stat button. You're going to scroll over to tests, and you're going to want the first option called z-test. Right? And I'm going to do this 3 times for you in the coming lecture here. So you'll get some good practice. Okay. So here's the first one about Netflix. So a study conducted in 2015 by the technology company Rovo, which is now called TiVo, showed the mean time spent per day browsing the video streaming service Netflix for something to watch was 19.3 minutes. Okay. So I'm sure, we've all watched Netflix, right? And so what this is saying is when you load up your Netflix, on average, people spend 19.3 minutes deciding before they actually watch something. Okay. Next, it says assume the standard deviation for time spent looking for something to watch on Netflix is 8 minutes. Okay, so you're given right here. You're given sigma is 8 minutes. And a social scientist is interested, a little bit of a typo, to know whether the mean time browsing Netflix has increased. Okay, so increased here, that tells me it's going to be a right-tailed test. Right, so we talked about this in some of the previous lectures. You look for these keywords. So suppose a social scientist takes a random sample of 50 people, so you're given the sample size is 50. And the mean time that they spent browsing is actually 21, so you're given X bar here, which is 21.5 minutes. Okay. At the 0.05 level of significance. Okay, so you're given your alpha. Right. Is there evidence to suggest that the mean time spent browsing Netflix has increased, right, from the 2015 level? Okay, so now we just need to go through the 5 steps. Okay, so the first thing is, what are we talking about here? So look back. The mean time spent browsing on Netflix has increased. So we're going to let mu equal to the mean time spent browsing Netflix. This, currently, right? No, not in 2015, because we know what it was in 2015. And now we have to set up the test, right? So it's mu is equal to something, and mu is now greater than something, because it's a right-tailed test. We'll go back. We know what it was in 2015, right? So your null is that there was no change. So you have to start with some base assumption. So we're going to assume that it's 19.3 minutes. And what we're saying is no way, no way. There's so much on Netflix now. It's had to have gone up. Step 2, select the level of significance. Well, that's alpha. So that's 0.05. At this point now, what we're going to do is we're going to go right to our calculator. So grab your trusty calculator. All right, it doesn't matter if you have the TI-83 or the TI-84, the options look the same. So you're going to press the stat button, and you're going to scroll over to tests. That's number 1 z-test. Now you're going to notice there's 2 options here. There's data. So if I give you the raw data, so in this section here, we're not going to be given the raw data. When we actually get to the t-test, I'll give you the raw data. So what we're going to do is we're going to scroll over to stats. That means you're given summary statistics. Okay, so now I see all these options. Scroll down. U sub 0, that's what's in the null. 19.3. Sigma, what did I say the standard deviation was? Let's go back. It was 8 minutes. X bar, that was the 21.5. And now what was N? N was the 50 people. So the next thing here you see, it looks like the 3 tests. So you just have to scroll over. This is your alternative and change it to a right-tailed test. You have to click on this, hit enter. And then you're going to scroll down to calculate. And you should see all this. Okay, this right here, this Z thing, Z is equal to, that's your test statistic. So it's 1.945. Okay, that's the first thing. That's the first is your test statistic. So it just gives it to you. And then the next thing you see here is P. This is your P value. It's equal to 0.02, I'll round it to 6. 0.26. Okay, so notice this is a little bit easier actually than the critical value approach. Okay, we relied very heavily on our calculator. Okay, so look here. Our conclusion. Our p-value, which is 0.026, is less than our level of significance. okay, our alpha. All right, so what do we do when our p-value is less than our level of significance? We reject the null hypothesis. Okay, so we reject the null hypothesis. Okay, so remember, when you reject the null hypothesis, you're saying that's not correct. There's evidence to support this. So evidence suggests the mean time spent browsing Netflix has increased since 2015. Yeah, and I think that's probably true. I mean, I spend a lot of time browsing Netflix before I finally decide on something, and I'm sure many of you do too. All right, so as you can see here, this method just really relies heavily on the calculator, and I personally love it when that happens. All right, let's do two more quick examples. Okay, so according to the most recent general social survey, this is about TV watching per day. College students watch an average of 2.5 hours of TV per day. So a certain statistics professor, probably me, at WCC, believes, a lot of typos in this, sorry about that, believes that students, sorry, at WCC watch less, all right, than 2.5 hours of TV per day on average. Okay, so I think they watch less. So that tells me right there that this is going to be a left-tailed test. All right, to test his claim, he samples 30 WCC students, so you're given, and finds the mean hours of TV watched per day, their X bar, is 2.35 hours. All right, assume the standard deviation for TV watched per day, so standard deviation is 1.75 hours. All right, at the 0.05 level of significance, okay, is there evidence to suggest that WC students watch less than 2.5 hours of TV per day on average? Okay. All right. Well, again, you're just going to go through the hypothesis testing, and we're going to rely heavily on the calculator. Okay, so define the parameter. So what are we investigating? We're investigating the mean hours of TV watched per day, and this is by WCC students. Okay, because I want to be specifically that WCC students watch less. So it's going to be a left-tailed test. So it's mu is equal to something versus no way, mu is less than. Well, we're going to assume right now that WCC students watch just as much TV on average per day. And what we're looking to show evidence for is like, no way, it's got to be less than that. Okay. Level of significance was given as 0.05. And now at this point, what we can do is we can hop right to the calculator. So I'm going to scroll back just so I see these numbers here. So the options were, you're going to hit stat, you're going to scroll over to tests, and you want number one, the Z test. All right, so your data from any previous problems you have in there will be saved in, so you just have to go over it. Our null hypothesis was 2.5. Standard deviation is 1.75. X bar was 2.35. And N, my sample size was 30. And so here you just have to change it to a left-tail test. So just have to click that one. And I'm going to scroll down to calculate. And you should see this right here. Okay, so my test statistic is negative 0.469. And my p-value, if you look here, p is equal to 0.1, or 0.319. Okay, so we'll look. Here our p-value is greater than the level of significance. right? Because 0.319 is greater than 0.05. So here we fail to reject the null. So when we fail to reject the null, what we're saying here is evidence does not suggest the mean hours of TV watched by WCC students is less than 2.5 hours per day. So I think now that you're seeing this, like the calculator just does so much work for you here that it's really just about like setting up the test up here, and then the correct conclusion. All right, let's just do one last one. This is about satisfied workers. So at a large company, the attitudes of workers are regularly measured with a standardized test. Okay, scores on the test range from 0 to 100, with higher scores indicating greater satisfaction with their jobs. The mean score over all of the company's employees was 74. Okay, so that's what they're telling me. The average of everyone was 74. With the standard deviation, so you're given the sigma is equal to 8. So right there, you're given. Some time ago, the company adopted a policy of telecommuting. Nice. Okay, get to work from home. So under the policies, workers could spend 1 day per week working from home. Okay, so here's what this is going with. Are people going to be, more or less happy with under telecommuting? I don't know. So after the policy has been in place for some time, a random sample of, sorry, a little bit of a typo here, 80 workers was given the test to determine whether their mean level of satisfaction, sorry about that typo there, had changed. Okay, had changed. Okay, so what does that sound like? That sounds like a two-tailed test. Okay, all right, since the policies was in effect. So from that, the new sample mean was 76. Okay, at the I'm sorry, I've done 0.05 level of significance a bunch here, but it's the most common one. At the 0.05 level of significance, can we conclude the mean level of satisfaction is different since the policy change went into effect? Okay, so let's set this up. All right, so what are we investigating here? So we're going to let mu equal the mean satisfaction level with the new policy, right? Because we knew what the mean satisfaction level was prior to the policy. So our null, we said it was going to be a two-tailed test, so it's mu is equal to something versus mu is not equal. Well, remember the null hypothesis is no change. Okay, so start with the assumption that there's no change, that it was still 74. And what we want to do is see if it has changed, that it's no longer 74. Right, so alpha is equal to 0.05. So let's go back. Sorry about the typo, n was 80 here. So we're going to grab our calculator, and we're going to hit stat. We're going to go over to test, and we want the first one, z-test. So you're going to scroll down. Mu naught, what was in the null, was 74. The standard deviation was 8. The new mean was 76. And we had talked to 80 workers. All right, and now we need to make sure that we change the alternative to not equal to. Then you're just going to scroll down and calculate. And this is what you get. We get z is equal to 2.236. And the p-value here is 0.025. All right, well, look, the p-value is less than the level of significance. Okay, so what's going to happen here is we're going to reject the null hypothesis. So we're saying, nope, 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 nope. This is most likely correct. And what's going on is evidence suggests the mean satisfaction level has changed since the new policy has gone into effect. I mean, I like telecommuting, so, I'm sure it makes people more happy with their jobs. All right, class, so I hope this helps seeing this video here. So just remember, when the p-value is less than alpha, reject the null. When the p-value is greater than alpha, you fail to reject.